The world around us is an amazing place filled with beauty and with science. But let's face it, sometimes the science can be so confusing that it takes a PhD to understand it. Well, you're in luck. I just happen to have a PhD. Come and take a seat. Perhaps I can explain the world around us in a way we all can understand. Welcome to Conversations in Science. I'm Dr. Judy L. Moore. Call me Doc.
All right, this is Jessie. I am so happy to be back with you guys. Yes, I know, it is Wednesday, and this is the first time I have gotten on air all week. All right, first, I'm sorry. Well, I got something special for you guys tonight. I'm not alone. Nope. I've got Dr. Judy L. Moore with me. Judy, come on, say hi to everybody. How you doing tonight?
Hello. Yes. Well, for you it's night, but for me it's the middle of the afternoon.
I know, time differences. And who knows when these people are listening, because guess what? They can...
It's downloadable.
Exactly, and including on iTunes. All right. Now, you've got a Juno update and a Jupiter update for us. I can't wait. We've been waiting to do this episode since you first since the thing launched or whatever it was.
Since it did its insertion in and around Jupiter's orbit. Yeah.
Okay, so since its insertion,
it's such a long time. Yeah.
Yeah, and we've had to wait, and you were always like, I checked the NASA site, there's nothing. I checked the NASA site, there's nothing. And finally the other day, I'll never forget when you hit me up and you're like, okay, I can do it now. And I'm like, awesome.
Yeah, no, they finally came through with the first of their flyby updates, which is fantastic. For those of the listeners that don't know, Juno is the mission that NASA is running to do science exploration around Jupiter, of course, the biggest planet in their solar system. And it's important to actually know that this has been something that's been in the works for a good number of years, because they launched Juno 5 years ago. So we've been waiting 5 years for them to get any sorts of data or any sorts of results from Jupiter, and the first lot of results are starting to come through.
Okay, scientists must be really patient people. 5 years? I know people that can't wait 5 minutes for popcorn in the microwave. Okay? I mean, really. So these people literally they launch this thing and then they sit on their hands and check on it every once in a while, and sat on their hands for 5 years.
Well, they would have sat on their hands for a bit longer, because you would have thought, how long does it take to build a special instrument that is going to be specifically designed for exploring Jupiter, only to destroy it in 18 months' time?
Wait a minute. They're going to destroy it? Okay.
Yes, they are going to destroy it in 18 months' time.
Okay.
I know, scientists are crazy. It's the things we do in the name of exploration and trying to understand the world. It's bizarre. It's crazy. I know.
Can you tell me why they're going to destroy it?
All right. The reason why they're actually aiming to the final phase of Juno is... All right, let me just take a bit of a step back here. Basically, Juno has got a variety of different mission steps to it. The primary mission that it's got is actually doing these flybys, and there's 36 in the sequence that they're going to be doing. So 36 times, Juno is going to be going very close to the planet and taking science instruments, different scientific measurements, and sending all of that information back to Earth. On its last flyby, they are going to be changing the trajectory of Juno itself and crashing it into the planet.
All right.
So it is not coming back. The reason they're doing this is because they don't want to contaminate anything else that's out there. There's always the risk that it could crash into something else, but it is locked into Juno's orbit. There's nothing else we can do about this, so we might as well just crash it into the planet. That way we can preserve as much as we can of the moons that are out there as well for future explorations.
Okay, so they're actually being kind of environmentally conscientious of space, right?
In a funky way, yeah, they are.
Okay, that's a new one on me. That's a new one. I mean, I've heard recycle. I've heard don't throw your little plastic six-pack thingies in the ocean or in the, out without cutting them up because it could trap some poor animal. I've heard heard them all. At least I thought I had until today. So that's a new one, Judy. You got me. You got me. So,
well, like I said, they're going to be crash landing it, so it's going to be interesting.
All right, now I know you. You've got your PhD, which means there's one thing you do and you do well. You do research.
Yeah, just a bit. I'm a bit research mad.
All right. Crazy. And I know you wouldn't have told me you were ready to come on the show without a stack of research sitting next to you. So.
Oh, of course, and it's right in front of me, all these funky numbers and everything. Yeah, doing all the calculations. Definitely.
All right. So
what do you want to know? That's what it comes down to.
All right. How fast is this thing going? And by the way, any of you out there listening, feel free to jump in the chat room. If I can always read your questions out. Be happy to do so. We don't have anybody yet, but hey, I'd love to have some of you in the chat room. I am actually in the chat room tonight. I'm not always there. I'm trying to make a habit of it. So bear with me, guys. All right. So how fast does this thing go, and how close is close?
Okay. Well, let's start with the how fast this thing is going. When it did its latest flyby, it was going at 130,000 miles per hour. And for those who are working in the metric system, that's 208,000 kilometers per hour. I'll give you a bit of perspective here. A Boeing 747, its cruising speed is 550 to 600 miles per hour. It's quite slow. The fastest plane recorded, so the X-15, was recorded at a speed of 4,520 miles per hour. That's pretty fast. The International Space Station and any of the other satellites that happen to be orbiting the Earth as well, they are traveling at 17,150 miles per hour. So Juno was traveling easily 5 times that speed.
Wait a minute.
It was going around Jupiter.
So it takes more speed for Juno to orbit Jupiter than it does for the space station to orbit the Earth.
Yes, it does. And one of the reasons why is because the orbit around Jupiter is not circular. The orbit that the satellites have around Earth and the orbit that the International Space Station have is a circular orbit. But Juno is deliberately having an elliptical orbit, and that's to get it away from the magnetic fields around the planet for a period of time to give the instruments a bit of breathing space. We're not exactly sure what sort of radiation is coming from those magnetic fields, and we need to give the instruments time to recover.
All right, wait
from
a minute.
The radiation exposure.
For people who aren't good with big words, elliptical, it's kind of like an oval shape, right?
Yeah, it's an oval. Yeah, sorry.
Okay. That's okay. Hey, I've had some goofy questions before, so I figured let's make sure everybody understands, and I think they can all understand giving the scientific instruments a rest, because doesn't everything need rest? So this thing, because it's going in an elliptical orbit, it has to be going 5 times faster than this International Space Station.
Yeah,
Whoa.
That's why. It's got to be that fast just so it can maintain that orbit and actually get away from the poles long enough to create that elliptical orbit. So it's an interesting, fun calculations that they would have done at the time when they created the trajectory algorithms.
Yeah, that sounds like it needs a lot of calculations, Judy. A lot.
Yeah, and let's hope they didn't get it wrong.
Wait a minute. What would happen, God forbid they'd gotten it wrong?
If they got it wrong, well, they could crash into the planet a lot sooner than they expected, or if they miscalculated, say, the trajectories or how the moons are moving. It could by accident intersect with one of the moons.
Okay.
If they also got it wrong and was moving too fast, it could break away from Jupiter's orbit as well and shoot off into space. So there are things that could have gone wrong, but so far it looks like we've got it all right.
So it looks like they actually used their calculators and side rules and computers and everything and got this right.
Here's hoping we did, yeah.
And when you say we, for those people who've never heard a show with you before, please remind everyone what you have your PhD in.
Sure. My PhD is actually in astronomy, and I also did an engineering degree as well, and I specialized in astronomical instrumentation. So I understand what the engineers who designed this system, designed Juno, would have gone through and pulling their hairs out, trying to get every single detail correct and making sure that all the instruments are working the way they need to. It is not an easy task, and for anyone who thinks it is, they are deluding themselves. There's a lot of engineering that went into the Juno and its instruments, and at various different stages by multiple different people.
All right, that sounds well beyond my math skills, Judy. It really does. I'm sorry, but okay, yeah, no. And I'm glad you understand this because, all right, now, what are some of the other, I know you have, so how close was close? You said it got close.
Okay. It got very close. It actually came, oh, I don't know if you want to consider it close or not, but I do. It came 2,600 miles just above the cloud, the atmospheric clouds. Now that doesn't sound like a lot for those who are working in the metric system. That's 4,200 kilometers. To give you again some perspective, if you were to drive from New York City to Los Angeles, you would travel 2,792 miles.
Wow.
So basically, the width of the United States was how close it came to the clouds. Now, that doesn't sound sometimes like it's very close, but here's an idea. Here, give you another idea. The International Space Station is 250 miles above sea level. So if we travel out into space 250 miles, we're going to encounter the International Space Station.
Wait a minute. So the International Space Station that we all think is way out there is 250 miles up.
Yeah, that's it.
How far is the moon?
Not very far. The moon itself is 239,000 miles out there. Again, we have this perspective of the moon being quite close, but it's not. It's quite a distance. So Juno moved even closer, significantly so. And when you consider how big Jupiter itself is, that's close. That's very close.
Now, if it tried to get closer, I'm guessing the gravity from Jupiter, I'm assuming Jupiter has gravity,
yes,
would pull it in.
Yeah, well, if it wanted to get closer, it would have had to been moving even faster to break away from that gravitational pull that Jupiter has. And that's the issues. It can only go so fast. So you would have had a known trajectory and a known distance that it can go that you know you can break away.
And they would have worked all this out. I'm assuming there was probably computer simulation and all that involved.
Oh yeah, and I can guarantee there would have been someone who sat down manually, double-checked all the numbers as well. You can't guarantee that.
Someone sat down with a pencil and paper or a marker on a whiteboard and literally did all these calculations by hand too?
I wouldn't be surprised if someone had. I really would not be surprised. I mean, if you look at it historically, that's exactly what happened when you had during the Apollo missions. You had the computers working out the calculations, but you had what they called human calculators or human computers that were double checking all of the calculations that came from those computers.
That blows my mind because, okay, you're talking somebody who I can make change pretty quick and easy without a pen and paper. But much beyond that, I don't even add a column of numbers without a calculator. I'm sorry.
Yeah, it is quite a scary thing, especially when you think about the time frame that the Apollo missions happened. But that's what they did. They had whole rooms of people who were basically double checking the calculations that came off those computers, because if they got it wrong, they got it wrong in a big way, and it meant lives. In this case, we're not talking about lives because we're talking about just a satellite, but it's still a lot of time and energy that's gone into those calculations. You want to make sure that they're right, because it's wasted years if we get it wrong.
All right, so how much information are they really going to be able to gather if that thing is going that fast?
Well, think about your camera itself. Okay, you're talking about just your smartphone camera. Think about how much data comes off of that thing. You're not taking a lot of data at a period of time, but it's still big images, and we are talking, what, gigabytes worth of images nowadays?
Sometimes.
Yep. Okay, well, this thing, Juno, as it was going around Jupiter, it collected roughly about an hour's worth of data as it was going from pole to pole, and it collected those images at an insane amount of rate, multiple different instruments, multiple different cameras, and that's the other reason why it needs to take a break, because it has to be able to send all of that data back to Earth before it goes for another pass. It has to dump all of its data eventually into the data link. It's going to take time.
Because they're going to crash it, and they won't be able, if they screw up getting that data, they'll never be able to get it again. Now,
exactly.
What's the most interesting thing you found out about Juno? Something that what's the most interesting or unique thing you found out?
There's some pop culture on Juno. I was looking at some fun
culture on something flying around Jupiter.
Yeah, exactly. I had fun looking at, there are various different press packets that NASA had done. Are you aware that they had created 3 special little Lego figurines, 3D molded, and they had actually put them on Juno and then launched it. So they have a little Lego figurine of Galileo, and we're talking about the ancient astronomer that's, over 400 years ago. And then we have a little figurine of Juno, who is actually the Greek goddess who was married to Jupiter. And of course, they've got Jupiter as well. All these little figurines, and they're so little cute. I wish Lego would actually make them into proper figurines so I could buy them. They were so cute. But no, they're 3D special 3D prints that they did, and they're on Juno, and they're never coming back.
Now, did Lego actually make them, or did NASA make them, or didn't the article say?
The article didn't say. I'm guessing that it was just someone that just had so much fun and was just being in the geek mode.
That is definitely, though, something interesting and cute. Now, when you first discussed this, you talked about how much it took to power this thing. How much power is behind this fast-moving orbit?
Okay. When I spoke to Rick about that, I think I got my numbers originally wrong in that when I spoke live, and I did some double checks and quick calculations. It is only 500 watts that it takes to power Juno.
Wait a minute.
To give you an idea,
I have a 50-watt light bulb sitting right in the light right next to me.
Exactly. So the amount of power that it takes to power every single system that's on Juno, it's only the power for 10 light bulbs.
10 light bulbs. I have that in my living room.
I think most of us would struggle to power our homes off of 10 light bulbs worth of power. I really do. But to think that they've built this incredibly complicated scientific instrument, launched it into space, and it is operating off of that much power.
That's not much power. I mean, I figured this thing would have like some big nuclear component to it.
Oh, now, so here's the thing. Juno is solar powered. There is no nuclear power on it whatsoever. It is 100% solar powered.
Is that what makes it safe to crash into Jupiter?
That's what makes it safe. Because we know that there is no nuclear signatures on it, we know we're not going to be contaminating the Jupiter atmosphere with nuclear signatures. That's one of the reasons why they've decided to go down this road. And it makes it a little bit more eco-friendly in that respect. But yeah, it's solar powered, and it's the furthest that we have sent a solar powered instrument into space. Hence the reason why it's so exciting.
Oh, it is kind of exciting, and you're even getting me excited about it. And you know my extent of astronomy, right? Yeah, the moon's out there. There's a star. I couldn't tell you what it is.
I'll get you converted yet, I'm sure.
You keep trying. You keep trying. I can be stubborn, Judy.
Yeah, I know. But that's okay. I'm still going to try.
Oh, I know. And that's one thing that is always fun about having you on, because you're so knowledgeable and you're just as stubborn as I am in some aspects.
Yeah, probably. But that's okay. Hey, will be interesting to find out what they come up with, though, with Juno. They haven't released any of the results yet, so I don't know exactly what those preliminary results are, but they have released some pretty cool images from Juno Cam. Juno Cam, I probably should explain this, is basically, it's just a camera, just like you would get on your cell phone. It doesn't have anything. It's no real science instrument. All it's doing is it's taking pictures, and that's all it's doing. And they've already released, NASA has released an image that they took before insertion that actually had Jupiter along with 3 of the Galilean moons in it. The Galilean moons, for those who don't know, are the 4 moons that Galileo had found and traced and named 400 years ago.
All right.
So they're the largest of the moons.
How did he find these things 400 years ago? I mean, binoculars?
Well, not far from the truth, really. What Galileo did is he created a telescope that was about 2 inches in diameter. So he polished and refined glass as much as he could and created this telescope with 2 lenses that was around 2 inches in diameter. And he would set it up and look at these wandering stars, and that's where the name planet comes from. It actually means wandering star. So he would trace these things, and he was mapping it down, and astronomers 400 years ago also had to be artists. They could draw so much better than I can. I wouldn't have a clue on how to draw over half the stuff they would have drawn. But he traced down exactly where various different dots were in the sky. And while he was doing this, he discovered a pattern. He could see with his little telescope that he made 4 dots that frequently orbited around what was called Jupiter, and what we had the planet as a consequence. And he decided that they must have been moons, not stars or planets of themselves. And so that's how he discovered the 4 Galilean moons. They're the only moons that we can see with a telescope that small. If you want to see the other ones, you have to have a much larger telescope.
Okay. So you actually can take like a regular telescope, like the one you would buy for your teenager that wants to look up in the sky and stare at stuff. You could actually take that telescope and see.
Yes. You can see 4 moons, and you can see them orbit and trace them, and you can actually see them move. And depending on how long you really want to sit there in the freezing cold of the night and actually watch the stars, you can actually trace them over the course of a night and watch these 4 dots move with respect to Jupiter. It's really awesome to do.
All right. Why would it be freezing cold?
Well, you're doing it at night, to put it blunt.
Well, yeah.
Not only that, the best viewing time for Jupiter, or at least from where I am, is actually winter, because you're going to have a longer night. And
okay.
yeah, and you're also going to be, Jupiter is going to be more on in those field of sky, in that particular frame of sky, or at least where I am. There are other parts of the world where summer would be the better field, but even then, sitting still at night when there is no sun to keep you warm, I'm sorry, but it's cold.
I bet. All right. So, I'm just trying to cover these things because I can imagine somebody going, wait a minute, why would it be cold? Why, why couldn't they just turn on a heater,
No, you don't want to turn on a heater when you're doing observational work in astronomy for a variety of different reasons. One of them actually being you'll actually destroy what you see. Look at it from this point of view. When you look at the stars, have you ever noticed how sometimes they twinkle? You've got this, and you notice how sometimes they twinkle more than other times. Sometimes they seem really quite still and they only do a little bit of a twinkling, but sometimes they're really, really twinkling and they're like, oh my God, it's like, is this thing going to stop?
It's almost like they're winking at you.
Yeah, exactly. And what that is actually our atmosphere. It's the temperature differences from the ground to above ground that's causing the air to wobble, for the lack of a better term. And as a consequence, the stars are just going bazonkers. The light coming from them just doesn't quite know which way to travel through the air. Now, if you turn on a heater, you're going to make it worse where you happen to be sitting, because you're making the temperature differences between the ground and the stuff just above you even bigger. And that hot air rises,
right.
It creates that heat temperature moving, and the air just goes all over the place. The light's going to go all over the place, and nothing's going to look stable. It's just, you don't want that. You want things to be as stable and calm as possible. So one of the ways to do that is to make sure everything's cold, really cold.
I'm sure you had your share of cold observation nights.
Oh yeah, definitely.
I'm sure you could tell tales on that one.
Oh yes, including me sitting on the dome floor with a sleeping bag wrapped up around my face, and all you could see was my eyes and my nose while I was watching the monitors, and everything else was just like, I'm cold, I don't want to move.
That sounds very chilly.
It's called dedication, and that's one of the reasons why scientists are a creature of their own. And that's probably coming back to one of the things that you were asking me about right at the beginning, waiting 5 years. That's probably why we do it, because we are so dedicated to the science. We will put ourselves into these horrible situations just to get the answers to those questions. And if it means we freeze, we freeze.
I'm sorry, but I hate the cold. I mean, I have a blanket, a heater. I don't do cold. I have an electric blanket on my bed. No.
Yeah, no, cold is okay for me as long as it's not too cold, but that's okay.
So pardon me, what's the longest you ever sat still doing an observation in the cold?
The longest I ever sat still. Oh, well, I didn't really have to sit still for too long because most of my data runs lasted for only 2 minutes when I was doing observational work. It came down to, when I was doing my observational work, it came down to the amount of memory I could put into my computers. I was recording in the order of about 100 frames a second, and I could only record 2 minutes worth of data before I had to flush the buffers. And to do that, I had to manually do some bits and pieces and enter in things. So I think me, it was 2 minutes was probably the longest, but I know there are some people that have run things for hours on end, occasionally going through and just checking to make sure that they haven't tracked off star or anything like that, doing slight readjustments here and there. But yeah, mine haven't been very long.
A few minutes I could handle. I can put up with anything for 5 to 10 minutes. You get me much beyond that? Where's my blankie? Where's my heater? Where's my mug of hot chocolate?
Yep, it got to the point when I was doing observational work, I would set the computer going, set the cameras going, go into the data room where there was heaters and warmth and a TV, and I would sit there for about a minute, maybe a minute and a half, and then slowly meander back up to the dome floor and make sure that things hadn't gone crunch while I was away, realign if I had to, and set the next lot of data going. So yeah, I got lazy towards the end. I wanted warm.
I don't blame you. And I'm guessing it all worked out. So, hey, you got your PhD.
Because I've got my PhD, yeah.
Right. I mean, come on here. 2 ounces of common sense. You got the PhD, so it must have worked out. All right. So, is there anything else I missed asking you that you really wanted to share with everybody?
No, I can't think of anything else. All I can say is that I know Juno's next flyby for Jupiter is going to be in about another 2 months, so it's going to be some time away. And then after that, it's going to be about every 14 days. So the first 2 flybys that it was doing are sort of preliminary, sort of last-minute maneuver things to get it into the proper orbit that it had to do for the science runs. And then the science runs are the last 34 flybys that it will be doing. And after that, it's called crash land into the planet and go bye-bye.
Wow. Like I said, I'm amazed by this whole thing. All right. It is well past the bottom of the hour, everybody. There is another show tonight, right on my heels. Wence's World had some technical issues last night. So I only have about 15 minutes left in the show. So we're going to take our commercial break right now. And I will be back with you after that commercial break. And we are going to do the quickest news wrap-up you've ever heard me do. Because, boy, is there a lot of news to cover. But I wanted to hear about Juno and Jupiter. It's more fun than talking about terrorists all the time. Right, Judy?
Of course.
I mean, I'm sorry. The terrorists are just no fun. So,
no.
All right. Let's take that brief commercial break. And by the way, thank you very much, Dr. Judy L. Moore. And if people want to have a question they didn't think of tweeting out or contacting you with me or you with while we were on the air, where can they reach you?
They can reach me on Twitter at Judy L. Moore. Or they can reach me on Facebook. I have my own Facebook page. Again, Judy L. Moore. They can also check me out on my personal blog, judylmoore.com. Or alternatively, they can go to the editorial business that I happen to run, which is Black Wolf Editorial Services, blackwolfeditorial.com.
All right. Well, we'll probably be hearing one of your ads in a few minutes. So, all right. Thank you very much.
You're welcome.
And let's go take that commercial break.